Okay, guys, welcome. Today we're going to talk about statistical tables and graphs. So we'll talk about different visual representations that we can use to display data. Now, the first type of table that we're going to talk about is what's called a frequency table. Now, a frequency table is probably what you think of when you just think of a table, but it shows the number of times or the frequency that each value occurs. Now, a basic frequency table will have two columns. So the first column will, of course, list all the categories of data, and the second column will list the frequency of each category, which, of course, is the number of data values in that category. Now, there are two common variations on the idea of frequency. We can have what's called the relative frequency, which is essentially where you express the frequency as either a fraction or a percentage of the total. And then you have the cumulative frequency, which is the number of responses in a particular category and all the preceding categories. Now, you might use a cumulative frequency for something like passing grades of at least a C or at least a B or at least an A or something like that. So that would be an example of a cumulative frequency table, because everybody that has an A also has at least a B and at least a C and so on and so forth. So of course, the way that we calculate relative frequency we would take the frequency in a particular category and divide it by the total frequency. And then of course, if you wanted to express it as a percentage, you would multiply it by 100 as well. Right? And then as we said before, to find the cumulative frequency, you would take the number of data values in that category, and then you would add all the data values in the preceding categories after that. All right, so let's go ahead and let's look at an example. Now we have this frequency table where we're given the grade and the frequency representing the number of students that earn that grade. All right, so we're going to make an additional column for the relative frequency, and then we'll also make one for the cumulative frequency. All right, and here we'll take preceding. I know sort of the example that I just said a moment ago said that we would count C's as also being like a passing grade for an A, but I think this might actually come out to be, oh no, I think this is exactly what I was saying actually. Okay, but anyway, so the relative frequency would just be to take, for example, for this A column, we have 4 out of 25. Right? And of course, if you wanted to make this into a percentage, you would multiply, this would come out to be a 16%. Okay. If we do for B, that would be a 7 out of 25. And of course, that would be a 28%. And then of course, for 9, that would be a 36%. For 3, that would be a 12%. And for 2 out of 25, that would be an 8%. Right, and of course the total would be 100%. Now for cumulative, what we do, change colors here, is for the first column, we just take 4 because there's nothing that came before that. Now in the next column, I need to take the 7 plus the 4 that came before that, and I'm going to get 11. Then for C, I need to take the 9 that I'm getting and add the 11 that came before, which will give me 20. Just box them to indicate that that's what we want. And then for the next one, of course, we would take the 3 and add 20 to give us 23. And then finally, in the last one, we would take 2 and 23 to give us 25. So that's what we mean by calculating relative and cumulative frequencies. Okay. Now next we can talk about two different types of data. So there's qualitative data, which is going to describe qualities or categories. An example of this would be the one we just looked at, where you had different grades on a report card. And then you also have quantitative data, which is some sort of count or measurement. right? So this is the way that I usually like to think of this, is that quantitative data is purely numerical, right? So for example, the number of correct answers that are on a test would be an example of quantitative data. So let's look at some additional examples. So in part A, we have brand names of shoes in a consumer survey. So of course your brand names might be like Nike, Reebok, Adidas, things like that. So this is of course qualitative data. For part B, we have heights of students, and of course you would classify heights using numbers, so this would be quantitative. Quantitative. Now for part C, it's a little interesting because we have audience that is ratings of a film on a scale of 1 to 5, where 5 means excellent. So you have to be a little bit careful here, because even though we have these numerical ratings here, they are representing qualitative data because they're representing sort of these categories that are describing the thoughts about the movie. So this is sneakily qualitative. Right, so you have to be a little bit careful when things are worded that way. Okay, now the next type of data classification that we're going to need here is what's called binning. Right, now a lot of times when you collect data, it's not practical to consider them all sort of under the same umbrella. So the idea is that what we do, we group or bin the data into categories that cover a range of possible values. So I'll show you what we mean by that. So for example, we have the following set of 20 scores from a 100-point exam, and we have all of these numbers. So of course, determine appropriate bins and make a frequency table. Now, the idea here, as far as making appropriate bins, is that there's not one clear perfect answer, but in a lot of cases there are ways to bin that make sense. Now, since I've taught, to me the bins would be to group these by 10. Right, because that would break them down into grades for me. So I would think 90 to 100 is one bin. I would think that 80 to 89 is another bin. 70 to 79 is another bin. I don't know if there's any 60s in this data set. But let's go ahead and we'll make a frequency table. So now these are sort of my categories for my frequency table. So now we want to make a frequency and then a relative frequency and a cumulative frequency. And then of course we'll interpret this. And let's get a column for the total, because we know that in total that there's 20 scores. Right, so let's count all of our scores that are 90 to 100. So it looks like we have a 94, 98, and a 91. And so it looks like we have 3 that are fitting in this category from 90 to 100. Now for the 80s, it looks like we have 1, 2, 3, 4, 5, 6. So then, of course, we should find that the remaining 11 are in the 70 range, right? So if we do that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and in fact, there are 11. Now for the relative frequency, we know that there's 20 total, so these are just going to be out of 20. So 3 out of 20, 6 out of 20, and 11 out of 20. And if you wanted to make these into percentages, this would be a 15%, this would be a 30%, and this would be a 55%. Now for the cumulative frequency, again, we know that the way that we do that is we take the number in that category and add everything up that came before it as well. So for the 90 to 100, all I have is the 3. Now in 80 to 89, I have 6 plus the 3 that came before it, so I have a 9 total. And then, of course, for the last one, you should always get the total for the last one, so we get the 11 plus the 9 that came before it, so then that would give me the 20, of course. Now, the way that we would interpret this cumulative frequency is the same as we did before. What the cumulative frequency represents in this situation is that it represents the number of students who got at least this grade. So for example, if you look at the 80 to 89 column, our cumulative frequency is 9. So that means that there's 9 students that got at least an 80 to an 89 on this. And of course, you're including the 3 that are in the 90 to 100 column, because that, of course, is at least 80 to 89. Okay. Now, the next type of graphs and charts that we'll look at are what are called bar graphs and pie charts. Now, a bar graph uses a set of bars to represent the frequency or relative frequency, in some cases, of each category. So the higher the frequency, the longer the bar. And of course, you can also have bar graphs that are vertical or horizontal. Most of the time, the bar graphs seem to be vertical, but that's just seems to be personal preference. And of course, bar graphs are probably something that you've seen all the time. And in this particular example, we have the students' favorite juices, and I guess in a particular class, and then of course the numbers are based on red, orange, yellow, and purple. Now, some important labels that you need for a bar graph would be, of course, the title or the caption, or in both in some cases. And of course, this would explain what is being showed and would list the source of the data. And of course, that would come in the caption. So of course, it might be something like, what is Americans' favorite food, or something like that. And then the source might be the US Food and Drug Administration or something like that. Of course, the next thing are the vertical and horizontal scales and titles. And of course, for the vertical scale, you have that those are, of course, the numbers along the vertical axis. Now, you should also line these up with hatch marks or tick marks, and these would precisely locate certain numerical values. And of course, same thing for the horizontal scale, but you should have tick marks that are used for quantitative data if that's what the type of data that you're displaying. And if there are multiple data sets being displayed on a single bar graph, you'll also want to include a legend to help the reader identify which data sets are being shown for certain colors or things like that. Now, pie charts are usually used for relative frequencies because the total pie must always represent the total relative frequency of 100%. So of course, in this example, we have favorite types of movies being surveyed, and it's displayed by this pie chart here. Okay, now in the next example, we have that carbon dioxide is released into the atmosphere primarily by the combustion of fossil fuels like oil, coal, and natural gas. Now, this table on page 314 that I've copied for us here lists the 8 countries that emit the most carbon dioxide each year. So we're going to make a bar graph for the total emissions and also for the emissions per person, and we'll put the bars in descending order of size. And the nice thing, it looks like the data, at least for the total carbon dioxide emissions, is already organized for us, right? So your bar graph might look something like this. Let me give myself a little bit of room. And we'll just do the bar graph for the total carbon dioxide emissions. And if you want, you can try doing it for the per person carbon dioxide emissions on your own. So feel free to pause it and you can sort of look at the data and make your own chart here. But I think we'll drive the point home just by looking at the total. Okay, so first of all, the title, we could make carbon dioxide emissions by country. And emissions has one M and two S's. So something like that. Now our 8 countries are China, United States, Russia, Japan, and then India, Germany, and then we have Canada, and then the United Kingdom. Okay. Now it looks like our highest data set is at 6,534 and our lowest is at 572. So it probably makes sense to do these by 1,000. So let's do that. So we'll say this is the emissions, and we'll say in thousands. And I believe that the thousand, so we need actually 1,000 millions of metric tons, which would be billions. So now I can just get away with using 1, 2, 3, 4, 5, and 6. We'll go up to 7. So of course I could have just left it, and as long as I counted by thousands, I would have been okay. But just to cut down on the writing a little bit, we'll word it that way. Okay, so of course now the next thing is to plot each of the bars. So it looks like for China we have 6534. So I would need my bar to go somewhere around here. So something like that. For the US, we're at 5833, so we have somewhere right about here. For Russia, we have 1729, so pretty big drop there. For Japan, we're at 1495. For India, 1214. A little higher there, maybe something like that. For Germany, we're down to 829. And then Canada, 574. And the UK, 572. So those are pretty similar. So that would be a typical bar graph or something like this. And of course, this isn't perfect. This is just sort of a rough sketch, but that's the idea. And of course, you could do something similar for the per person carbon dioxide emissions, but we'll just do this one just for the sake of time. Now, in the next example, we're going to make a pie chart. So among the registered voters in Rochester County, 25% are Democrats, 25% are Republicans, and 50% are independents. So we'll make a pie chart showing the breakdown of party affiliations in Rochester County. All right, so of course the pie would be a circle. Now half of the circle would be 50%, and half of one of those halves would split them each into 25. So we could say that 50% are the independents, and then 25% are Republicans, and 25% are Democrats. So something like that. All right, so that's a typical example of a pie chart. Now the next type of table and graph that we'll talk about is what's called a histogram. Now a histogram is basically a bar graph, but here all the data categories are quantitative, right? So instead of having like countries down here like we did in the last example, it's purely numerical data on both scales, right? So in this particular example here, we have heights. Now the bars on histogram must follow the natural order of the numerical categories, right? So if you see that these heights go from least to greatest, right? So they sort of have a natural progression. And the widths of the bars have a specific meaning. So here you have that the widths of each bar include from 60 to 65, right? And then the next one, 65 to 70, and so on and so forth. Now, a line chart is similar to a histogram, except instead of using bars, it's going to plot each point here, right? So if you look at this example, we have each of these points that are being plotted here, and then they're connected with a line. So of course, because these are used to show how something is going to change with time, a lot of times we'll also refer to these as time series graphs. Now in this next example, we have that this table on page 319, which I've copied here, shows the ages at the time when they won the award of all Academy winning actresses through 2013. Now we're going to make a histogram and a line chart to display both of these data, and we'll sort of discuss how this looks. Okay, so first let's go ahead and we'll make a histogram. So for our histogram in this case, we'll put the frequency, of course, on this axis, and we'll put the ages on this axis. So now, of course, we want our data to be following sort of this natural progression, so we'll go by tens. I need to go all the way up to 90. Now, it looks like for my frequencies, we have as high as 34, so maybe it makes sense to do this, we'll say by tens again. So we'll say 10, 20, 30, and 40. So now for the histogram, I would need to do something, and I'm actually going to copy this because we're going to need it to make the line chart. So let me copy that. Okay. Let me give myself a little bit more room, and we'll just paste it below. Okay, perfect. So now, for the histogram, we're going to have something like this. So from 20 to 29, we have 30 actresses. So I need to make the width of the bar span from 20 to 30. We're going to have something like that because we have 30 for 20 to 29, and that bar is covering everything from 20 to 29. Now from 30 to 39, we have 34. So this needs to go a little bit higher. So we're going to have something like this. And then, of course, from 40 to 49, we're down to 13. And then from 50 to 59, we're only at 1. From 60 to 70, we're up to 6. And then for the other two, we're down to 1 again. So something like that. So that would be an example of our bar graph, or sorry, our histogram. Now, for the line chart, we're doing the same thing. So we're plotting the same data points, only it's going to look a little bit different in the end. So from 20 to 30, we are at 30. So we're going to have something like this. From 30 to 40, we are at 34. From 40 to 50, I think it was 13. Yes. So we're now down to here. From 50 to 60, we're at 1. And then up to 6. And then down to 1 for the last two. So now, of course, we're going to connect all these with lines. So we might get something like this. So that would be our line graph for the same data, right? So both of these graphics here are displaying the same data, but just note the difference between the histogram and the line chart. Okay. Now, I just did sort of a rough sketch of this time series graph that you can find in the textbook, but this shows the graph of the homicide rates in the United States, and then down on this bottom axis they would have the years. So of course, what does this show? This shows that in these years you were at a lower rate, and then you're coming up to this part here, so it's increasing a little bit for this part, and then you decrease again back down here, right? So you can sort of use a time series graph to quickly show what's going on with a particular data set. All right, so that concludes this video on statistical tables and graphs. I hope you enjoyed, and I'll see you next time.